So, welcome, Deepak. Thanks for taking time out on this AECORD session. To introduce everybody to Deepak, he heads the firm by the name Mindwagon, and his expertise has been in climatological design, building energy performance analysis, and a lot of work has gone in terms of all the green and sustainability analysis that is required for GRIHA, IGBC, B Energy, ECBC, and many other such standardized green rating agencies that we associate with. So, Deepak, over to you. I think all of us are really curious to know about this topic that you have chosen to discuss with us today. So, please go ahead. Welcome.
So, good evening, everyone. So, we are touching upon a topic today which is a bit sensitive in terms of where actually we are heading in terms of green building revolution. Worldwide, already this topic of regenerative architecture has picked up, where people are doing their extensive studies on it. People are doing PhDs on it. So let us see our journey till now, where we are talking about regenerative architecture. Where have we started, and why are we talking about this topic today, and why actually we really talk about sustainability in buildings? Yeah, next slide. So as many of us realize this, what I have tried to show in these images, one thing is, as ancient architecture, we have all been, mankind has been living in very, downscaled structures, and having even living spaces below the earth. So we have really scaled up from there, and we have reached a situation where we no more expect the natural elements to protect us, and we have been really growing very fast and vast and taller. So the other two images, what you see is something what we are in today's situation, where nature can no longer protect us naturally. So we have started getting the nature scale up the buildings, and today we are into regenerative architecture, biophilic design, and things like that, where to still have a biophilic design, we try to have terrace gardens and trees, plants, everything coming on the facade roof. So today we are in this particular stage of architectural design, where we really need the nature's touch and protection, but we are trying to scale it up over our buildings. So just trying to learn from nature is that how birds and ants and other species on earth really live with the nature, and how they modify their living space or habitat, what we call it as, which is an integral part of the nature. So be it a bird's nest or ant hill, there is a lot of thermal physics in it. If you see a cross section of an ant hill, the whole cool air coming in, warm air going out is all thought of, and obviously they were not taught as a course or any masters what we all do. It is all the part of the nature which is inherent in the nature in all species, that to modify their habitable space in a way that is comfortable to live. So starting from why actually we talk about green buildings today is, in the past, the architecture had to be sustainable because the resources were very less. We hadn't explored the complete potential of electricity generation. We hadn't explored complete potential of renewable energy. So they were most of the resources were not explored, I could say. And today we have explored the resources, and we have reached a stage where we are exhausting the resources. So it is like the past we had resources were there, technology was less to explore those resources. Now resources are depleting, and technology is increasing, and now we have reached a stage where stage 3, what you can see in this graph, where the resources are depleting, whereas we have the technology. So it is like, again, we are exploring more resources, and we are going through that cycle again. So somewhere on the right hand image where I show that there has to be a balance where we are over exhausting the resources, there needs to be a balance drawn with the human aspirations of development and urbanization and everything. We need to somewhere balance the resources what we are exploring, using, and we have to generate new resources and also use the existing resources responsibly. Why actually we require talk about sustainability today is the rising climate concerns, and we know that all the industrial development and the urbanization and infrastructure development is imposing a lot of pressure and stress on the ecosystem. So there is a lot of climate change which is happening. So we need to see a way that at least as architects and people related to the building industry, how do we do our bit to reverse the climate change concerns, global warming, and things like that. And the resource depletion is something which everyone realizes that today we really don't have uh, the energy resources and water resources what we really want. For example, in a place like Bangalore, the outskirts development which is happening, the city municipal corporation is already decided that they cannot give any Kaveri River water or anything to those developments. You have to use the groundwater is also depleting. So you need to really think, are the developments which are happening really have the carrying capacity and economic saving through efficiency. So though we talk about saving our environment and saving energy, saving water, always one question is asked from the clients is what is the saving you get? What is the by saving so much of water? When is my return of investment for the high efficiency fixtures what we are using? By going for an efficient chiller, by going for an efficient glazing, what is the return of investment? So yeah, that is the reality of the market, that with parallelly when we are developing new technologies to counter the challenges of depleting environment and resources by buildings or any other infrastructure, we also have to work out economic sense to it, where we talk about return of investment and how much we are investing, and if we put cost to each thing what we are using in the buildings like energy, water, and also intangible benefits of wellness of people and health of people, where indoor air quality plays a major role. We also need to put a return of investment and economic sense to it. Yeah, so it's a sustainability as such is on a holistic approach, a combination of all these four aspects, especially when it comes to buildings. So today, where we stand as sustainable development goals in India, in 2016, we were at 66.7 7 in terms of in the rating, and out of 100, and 2023 we are at 73.6. So this is something which we can be proud of, seeing the green building revolution in India. We have not only in buildings but many other fields of infrastructure and technology, we have been able to adapt sustainability, and and hopefully soon we will reach the 100 mark. But yeah, today's situation is we are doing good on the sustainability development goal front. So this particular graph, what you can see here, is developed by Sphera, which is a company which is doing very good in terms of sustainability development and technologies. So what they say is that conventional, maybe before 90s or in the early 90s, we were in a conventional scenario where negative impact on the environment resources were happening. And slowly in the late 90s and 2000s, we really started getting into the green revolution. To be precise, you can say green revolution in India started with forming of IGBC somewhere in 2002, 2003. Then now you can say that okay, we are slowly, or we are at least 25% coming closer to being carbon neutral. So the question is carbon neutral the end of sustainable design in buildings, or there is something more? When we ask that question to ourselves, then we come to know that till now we were just trying to make the negative impact zero, and we have still not reached there, because we are not 100% of our buildings are carbon neutral. So this particular thing where we call ourselves sustainable is completely sustainable, or many corporates declaring today the net zero benchmarks. They have set up net zero threshold, net zero benchmarks for themselves to reach net zero by certain number of certain year. So all these things are happening in the corporate and manufacturing world, and even today a lot of residential developers and commercial developers who are into commercial buildings, they are also declaring their ESG reports, where they declare the environment, social and governance aspects of their companies, and everyone are heading towards reaching here where they call themselves sustainable by achieving net zero. Now, after achieving net zero, we now talk about regenerative architecture, where we restore the ecology, restore the environment, and also we have a long way to go to the positive impact in terms of social and environment, what we call it as regenerative. And definitely I find that we are bringing back ecology by having native species and native species and adaptive species into our project, rather than thinking we have depleted the ecology. So regenerative architecture principles works in around 8 principles, what we say. So basically, regenerative architecture is an advanced approach that goes beyond sustainability. As I was mentioning, that we have to think of restoring the nature and giving back to the nature. So what is giving back to the nature? So okay, fine, we have consumed the land, we have consumed the forest and everything, but when we talk about restore, regenerate and enhance natural ecology, what I mean is what I just spoke, that okay, for example, if we take energy, if we take water, which are the resources we are consuming and which is depleting now, there can be methodologies and approach to design and operation of the projects in a way where we save water and give it back to the lakes. We treat water and give it back to the lakes, and excess water can be sent back to the lakes and ecosystem. And also we can generate, if we reduce the energy consumption of the project, our roof areas may be generating more energy by solar and wind systems, and you can feed it back to the grid. So there are examples worldwide, where we will come to it in the end, where we talk about few examples of regenerative architecture worldwide. So there are examples worldwide where the power is generated more than what the building is consuming, and it is fed back to the grid. So coming into so first principle would be working within nature's limits, where I was mentioning initially about the carrying capacity. You need to first assess what is the energy available, what is the water available. Today we know the reality that most of the projects in Bangalore are getting tanker water. So basically you are getting the groundwater from elsewhere and feeding into the big developments, which actually does not have that carrying capacity, and that is having different other impacts in terms of water table getting depleted. And also sometimes we have found cases where there are harmful pollutants in the deep groundwater, which you ignore conveniently. So today, even if we go to MOEF clearances, we have found in and around Bangalore, around Whitefield, they have detected harmful chemicals in the water when you go deep down the sources of strata of water. So there are some things, not just getting the water, but there are other things, other issues which are starting. So we need to be mindful into how much of loading we are putting on our infrastructure. And restore ecology. So basically, as I mentioned, support biodiversity, soil, water, and air health. So this is basically what I was talking about. How do you develop a land? Today in Bangalore, if you are in many other cities, the maximum footprint you can have in your project is around 50%. Now, another 50% of it, how do you develop it so that you have a good indoor air, good air quality, lot of biodiversity, you have more of Mother Earth rather than having podium-based landscape or terrace gardens as a more percentage. You try to plan in a way where you go for a multi-level car parking and reduce your basement spread, and you go vertical and have more of Mother Earth for your landscaping. Then you can grow more of wilderness on it, because podiums really can't take other than a few decorative shallow height trees and shallow plants and grass. So you really need to have mindfulness in how to retain that Mother Earth and see that you have a more wilderness kind of a landscape which can bring back ecology. Then systems thinking across the scale. So basically, we also need to think of systems, whether it can take whether it can be water systems or energy system. So are we really enhancing the energy and water systems for to load so much of building and population in a particular place? So it's a parallel thing of today. Why do we have STPs at community level or area level? Because there is a lot of residential setup in the cities, which you really can't have your own STPs and water treatment plants. So city municipality sets up STPs for you at a centralized location, and they also, in few cities in India, they supply that treated water to the suburban or the rural area lakes, and where fisheries and other development and businesses gets developed in the communities. So there are a lot of innovative thinking which is happening around how your projects really connect to the community and regional scale. To give you one example, in Jodhpur, Jodhpur was the first city where the organic waste from the city, the kitchen waste and the other organic waste from the city was decomposed into fertilizer and so sold to the farmers in and around the region for as a fertilizer. So that too, it was done through vermicomposting. So it is like at different community scale and city scale, you should see how your project interacts to have a circular aspect to the sustainability, how your waste gets treated and recycled and reused, how your water gets treated and recycled and reused, and what is the source of energy you use, and maximize your renewable energy. And also today there are a lot of methods to even consume renewable energy. It need not be just on your building, or what we call it as on-site or on-campus renewable energy. You can really think of wheeling renewable energy from elsewhere outside the city, because today in Bangalore, a lot of developers are wheeling renewable energy like wind and solar from places like Mysore, Biddi, Belgaum. So there are a lot of renewable energy plants which are set up, centralized plants from where developers are wheeling energy to and giving it to their tenants in the IT buildings. We are doing few projects in those buildings where we are taking advantage of renewable energy being wheeled by the developers. So it is something which is multidisciplinary now, and approach is multidisciplinary. You really don't have to put yourself in thinking that okay, renewable energy is something which I have roof area, I can do it, otherwise I cannot do it. No, that is not the situation. There are other ways to use renewable energy. So place-based design, so rooted in local ecology and culture. So basically, a lot of projects today, when you talk about residential or commercial, people are mindful. The corporates are mindful that okay, let us incorporate few of the local artisan works in the project. Let us incorporate the local urban farming into the project, where urban agriculture is a big thing today. Urban agriculture is something where people are growing their own vegetables, fruits, and other things in the project. So there is a certain approach which developers or the corporates are thinking. And net positive outcome is produce more energy, more water than you consume. So what I was mentioning. So basically, we need to be net positive. in the projects to give it back to the community, society, and nature. Then definitely there is one more aspect of circular use of resources where reuse, recycle, and regenerate. So reuse, recycle, and regenerate is applicable to all resources what we use in our buildings, be it water, be it waste, be it materials. So today, recycle, reuse, and regenerate are a huge impact aspects when it comes to any sustainable development, or if you talk about any green building certification or anything. These are very important aspects which carries more weightage when it comes to water, waste, and materials. So this is the circular use of resources. So basically, anywhere on an average in a project, when we talk about reuse, we are reusing around 80% of water for flushing, chiller water makeup, and irrigation, and we are recycling and reusing water. And when it comes to waste, most of the projects today, whether it's residential or commercial, have organic waste converters. In some projects where we have area, we go for vermicomposting. Otherwise, it will be at least a mechanical organic composter. Then regenerate materials. Today we have most of the, at least 50% of the materials which we are using in construction industry have at least 10 to 15, 20% of recycle content, post-industrial and post-consumer recycle content. So that is also a huge impact, reducing the load on the virgin resources, virgin material resources extraction for manufacturing. So it's again a considerable number when it comes to materials also. And long-term resilience is planned for future generations. So basically, most of the projects today are designed in such a way that you keep in mind the future modifications and future resource utilizations which may change, and how robust or resilient is your building systems and planning to take it. So examples of regenerative building practices, as we mentioned. So when we specifically talk about buildings, we talk about sustainable building materials, passive cooling and heating, daylighting, green roofs, and rainwater harvesting. So again, if we are again getting into the smaller circle of buildings, these are the aspects. So when we, as we already discussed, that sustainable building materials, like for 40 to 50% of the materials in the market today are sustainable in a way that they are using post-industrial or post-consumer recycled content. And also there are technologies which are developed for the manufacturing of the materials which have less embodied energy. So now, what is embodied energy? Many of us know that it's the amount of fuel for transportation, extraction, manufacturing, and also transporting it to the construction site. Together, cohesively, we call it as embodied energy. So when we talk about materials, we talk about embodied energy, and also we talk about how much of recycle content, or recyclability of the material. So that is about the sustainable material, right? And when it comes to passive cooling and heating, it is about how much of thermal comfort you can achieve in any project without dependency on the mechanical system. So like if you just go with a ventilation system, or just a passive ventilation systems like solar chimney, or a the stack effect, what we call it as, or something called as PDEC, what we have, passive downdraft evaporative cooling. So in arid climates, you may go for a passive cooling, and in cold climates, you may go for a passive heating. So how much of time in a year you can really depend on passive cooling and passive heating can dictate your energy consumption of the building being 40 to 60% lesser than your conventional air conditioned building. So when I say air conditioned, it can be heating or cooling. So air conditioned, when you replace your air conditioning with passive methods of natural ventilation, of cooling, or trapping the heat inside, and gaining heat from the sun heat and trapping it into the building, hence reducing the heating energy. So you can anywhere save up to 40 to 60% of your annual air conditioning load. When I say air conditioning, it's both. So coming to daylighting, definitely we have achieved in all most of the projects at 25 to 30% on an average. Our annual energy consumption of lighting can be reduced by integration of daylighting into the project. Now, daylighting integration into the project, does it just happen after an architect has already designed and a green building consultant comes to it? No, it does not happen that way. Once all these parameters uh, have to be considered by the architectural master planning and design, for the simple reason that daylighting concepts like daylighting, passive cooling are some things which actually dictates the floor plate depth, floor plate optimization, how much of depth of your carpet area is sufficed with daylight of 300 lux if it is an office building, or 100 to 150 lux if it's a residential building. That as per the international approach, at least 75, 70 to 75% of a carpet area has to be sufficed by daylight if you have to call your building as daylight sufficient. And if at all you want to install lightings which are dimmable and go for controls, save energy on the annual energy consumption in lighting, you need to at least have 300 lux in office buildings for say 60 to 75% of the carpet area, and 75 to 80% of the carpet area in residential buildings with 100 to 150 lux. So this does not just happen by giving a clear glass, or it does not happen just by the facade treatment and the fenestration design. This needs to start from the first line, what you draw on the zoning and master planning, what you start on the butter sheet. It needs to start from there, where you optimize your floor plate, where you decide your footprint in such a way that, okay, you reduce the heat gain, but at the same time you allow more daylight. So all these things needs to start from the drawing board in the very initial concepts. So green roofs, rainwater harvesting, and build sustainable building materials. Everything is a design phase decisions. We call it as a design phase decisions. These are not add-ons. In the sense, it cannot be done once you finalize your footprint, finalize your functions, planning of your functions within the building, and the height of the building. Everything is finalized, and later when you start thinking of the sustainability aspects, you really cannot do your best, because many things are finalized, BOQ is finalized, and clients have already tuned their mindset that this is my design, and everything becomes a certification exercise, or some things which you need to really compromise and just do it for the purpose of certification or marketing. Okay, so these are not some things which can be an add-on. So today there is a requirement in the architecture fraternity to consider all these aspects as a part of design from the very initial stage, rather than waiting for clients to appoint a green building consultant and he comes in and he has his own limitation because you have finalized many things. Okay, so this is the culture in architecture we need to really develop. And this is not just because we are talking about regenerative buildings, because we find this as a constraint even if we have to make the building and systems 25 to 30% efficient compared to your international benchmark. We find it a constraint when we are called in after the BOQ is finalized, or even after the building footprint, massing and function and planning is finalized. So calling any green building consultant at the right time, or even more important is architects even becoming equipped themselves to consider these things and incorporate it to a certain level in the conceptual design stage. So any other consultant who comes on board can enhance it and take it to the next level. So basically, benefits of regenerative architecture. So reduced environmental impact, which we have already spoken, that we have we have resources depletion, and we should use the resources judiciously, and we need to see that how we give back the resources back to the environment and ecology, and flora, fauna, everything comes under the reduced environmental impact. And improved indoor air quality. Now, improved indoor air quality in many of our projects today in the urban cities like Delhi, Bangalore, or Mumbai, we are facing this issue of PM 2.5 being more than the moderate limit, PM5 being more than the moderate limit. So even the norms or whatever the green building certifications, what we call it as, are becoming very stringent on the indoor air quality, especially in offices. So why is it happening? It is happening because of a lot of construction happening in the cities, and a lot of trees being cut, and a lot of land, natural land being disturbed. Because once the natural land is disturbed, it gives rise to a lot of dust and particles, which becomes airborne. So we need to really see how we control the dust levels in the city, be it because of the vehicles, be it because of the construction activity. There is a lot of airborne particulate matters which exists, and also the vehicles add on to the CO2 and CO levels, so which will again penetrate into the buildings through fresh air intake. So there is new stringent norms which have come into building air filtration systems, where we have to go for high level of filtrations to maintain a better indoor air quality. And in places like Delhi, we already know that okay, at least in office buildings, we have the option of putting up high efficiency filters and technology. But what about the residential sector? You really can't put up high efficiency filters and other carbon filters and other things in a residential unit in a tropical climate. So because we don't have centralized air conditioning systems, so it is more hampering to the residential building sector, where we have very bad indoor air quality in the urban scenario, and somehow we are enhancing our technologies in the commercial and office scenario, but residential still has a drawback of poor indoor air quality. Now, coming to increased efficiencies, definitely, as we have to save resources, means it is directly proportional to increasing the efficiency. So if you have to save water, you have to use less water, you consuming water fixtures, flush and flow fixtures. And if you have to save energy, you need to use efficient mechanical system, efficient electrical system. And also, more than anything, you need to monitor. Monitoring is a key today if you talk about reduced carbon emission, reduced greenhouse gas emission, reduced energy use. Everything is monitoring and improvisation. So now slowly we are coming out of a scenario where we are just certifying green buildings as a one-time thing and forgetting about it, even not even bothering about how it is working, whether it's working efficiently or not after a couple of years. Do you have the historic data of water and energy? Is your systems functioning the same way as it was new? Are you taking care of important things in your operation, AMC, annual maintenance or operation and maintenance? Everything was very conveniently ignored, and everything was seen as a business of certification and marketing. But even the certification bodies have come up with a very stringent norms after 2025, where everything has to be monitored in your building and proven by real-time data and logging the data to the certifying agency. So everyone are getting stringent about it, and it's a good thing that we are slowly coming out of the scenario where till now we were just giving incentives to the developers and corporates to have a green building, but now we are going hard on them to prove the performance of the green building in all the aspects, be it energy, water, indoor air quality, thermal comfort, materials and resources, whatever it may be. Everything has to be monitored, improvised, hard data based analysis and hard data based certification. So that's a very good thing which we are seeing coming up in the sustainability or in the green building industry. Now, I always say that okay, we have reached a threshold where, as I just mentioned, we were just giving incentives for people to talk about sustainability and have green buildings. Now, one more aspect which has come into the sustainability as a sustainability design is the enhanced comfort and well-being, which I briefly mentioned, of thermal comfort and health and well-being and visual comfort. So especially in commercial buildings, it has been analyzed and studied by a lot of universities abroad, that the thermal comfort or the indoor air quality, or not having view towards daylight from your office workspace, creates a lot of circadial issues in human beings, where it affects your night and day cycle, and it affects your sleep, and a lot of other ill effects on the human health happens because you don't have good thermal comfort, good indoor air quality, and visual connection towards outside. So everything comes together as a well-being aspects in the building. So today, after we know that, okay, we have enough technologies to save energy, enough technology to save water, now we are getting into the wellness, where IAQ, indoor air quality, indoor environmental quality, circadian rhythm, everything has to be handled in for the occupants in any building, especially in the commercial buildings, and to a large extent in the residential also, as I was mentioning about the bad air quality. Now, this whole thing, where people are affected in terms of their well-being and in terms of their performance in the workplace, they're affected because of the bad systems and quality of design. We call it with that terminology what covers, that is the sick building syndrome. So sick building syndrome is a scenario where occupants have ill effects due to the poor building design, maintenance, and operation. So challenges in building sustainable regenerative architecture is integration of advanced energy systems that can work efficiently with the utility grid. Yes, see, till now we are talking, we in all the green buildings, we talk about, energy, renewable energy, and, I am using 40% renewable energy, 30% renewable energy. But are we really generating that much lesser in your power grid generation? But the answer is no, because in many cities in India, or more majority of the cities in India, the power corporation is really not able to trace the efficiency measures and how much of power consumption is really reduced in terms of building use, and related to the power generation, which is actually related to the carbon emission, because most of the power generation is through thermal power plants, and they're really not able to reduce the power generation based on the consumption in the cities. So that's why today there are a lot of research happening in India on the smart grid systems, where there is a feedback grid, and power generation corporations really have an idea as to what is the optimal use of the city and how much they can reduce the generation part of it. But definitely, yeah, that is the future, where the smart grids will help them really optimize on the power generation, which gets related to the power consumption. Then development of new sustainable building materials. So today we are seeing in the market that there are a lot of materials where the recycled content goes up to 60 to 80%, and recyclability is 100%. So these are two different aspects which many architects get confused. So recycled content is always the post-consumer or post-industrial content which is already there in the material. And recyclability is after the life cycle of the material, how much of it can be recycled. So it is really encouraging to see that in the market we are getting a lot of materials which are taking care of this overall environmental impact in terms of extraction, manufacturing, and recycling. So we call it as LCA, the life cycle assessment, where for the systems and building materials, they do LCA analysis and see that you have very less life cycle impact for a material. Then developing efficient wastewater treatments and water conservation systems for the ease of building occupants. So this is also one of the major aspects where we have challenges, because today most of the projects are not able to maintain their STP treatment quality, water treatment plants quality, output quality. So generally what happens is after some time, when you are not able to maintain it, you don't have the human skills and the technological skills to maintain it. You bypass it and you start taking tanker water instead of using treated water for landscaping and flushing and cooling towers in the HVAC cooling towers. So all these things sometimes with your inefficiency in terms of operation and maintenance, a lot of things gets bypassed. So that's what is a challenge, long-term challenge to operate and manage the regenerative architecture project. Or even to say from my daily experience, it's some level of a challenge still exists with the so-called green buildings also, where we are just trying to we are still not reached net zero, but still we are trying to attain net zero, or we are below the net zero level. There also we are facing these challenges of operation and maintenance. Then next is the training and construction professionals in regenerative design principles and maintenance of renewable energy systems. So today it's a bit sad to know that most of the Indian power plants or renewable energy power plants, which are at very macro level and huge scale, are not treated as equivalent to the US green E energy, which is the green E is the in US certifying body for green efficient generation of renewable energy. So when we deal with rating system projects and all, and we apply for US rating, we find that okay, yeah, Indian renewable energy plants, huge plants, are not really recognized by their standards. And we are still okay, Indian Power Corporation is certifying it, but internationally, because of the operation and maintenance issues, and we don't have proper training, trained professionals to manage and maintain the renewable energy power plants. Somewhere down the line, we are still yet to push ourselves in terms of reaching that level of reliability on the renewable energy power plants. So yes, that is also one of the challenge when we talk about renewable energy regenerative architecture, because we, as I earlier mentioned, there is a main aspect of generating more and giving back to the grid. So these are few case studies of regenerative architecture worldwide. This is Build Center in Seattle, USA, where you have a net positive energy. Rooftop solar panels generate more energy than the building consumes, and longevity by design is 250 years lifespan. That was analyzed and certified by building experts. And water regeneration, composting toilets, rainwater harvesting. So as you see that the one thing I want all the architects, at least in today's session, to observe that how renewable energy systems can be made part of your architecture. So here you can really see a very bold statement done by solar PV panels, which is extending beyond the building edges, and it makes a very strong statement. So this is one reason why I always say that architects have to get equipped with sustainability concepts and approach, because this can be taught by an architect during a conceptual stage where he is imagining his building and the design approach or design intent to his building, rather than someone coming and imposing it on the building later, right? So that is one of the reason why we say that okay, it is high time that we bring the sustainability aspect into mainstream architectural design and planning rather than a afterthought. So this is a beautiful building in China, where you have the double skin facade, wind turbine integrated between the floors, and it's an amazing thought where wind turbines are not at all seen as a add-on on the building. It is just integrated into the building, and also creating a positive Venturi effect, where the velocity of the turbine increases and you generate more energy. So the whole building is designed aerodynamically, having the turbines between the floors at two intermediate levels, and creating a high pressure ventilation through the blades so that it generates more energy. And thermal efficiency. So this building was built some years back. So the radiant ceiling cooling. We know that today in India, radiant cooling is talked about, but really not done much in projects. Other than few corporates like Infosys have made it a mandate for all the tropical climate, other than humid climate or coastal climates. But yeah, radiant cooling is the most efficient way of cooling, and heat recovery systems are there, but we really don't see that as a part of design. For in a multi-tenant developer project, it is a constraint, but at least in single corporate buildings or institutional buildings, we can really think of radiant cooling, which is the most efficient cooling system, and it can save up to 60 to 65% energy compared to your conventional air conditioning. So then the Omega Center for Sustainable Living in USA. So again, it's a net positive solar tracking system. So till now in India, we don't have a solar tracking system. Means as we all know from climatology, what we would have studied in architecture, that any surface which gets perpendicular solar radiation gets more solar energy. But as the sun keeps moving, our solar panels are static, and if you really track your solar sun with the solar tracking system, and you start turning the panels in such a way that solar insolation is perpendicular to your solar panels, you can generate more energy out of it, right? So that is something which is lacking in Indian market, where we are still struggling with the solar panel efficiency, but we haven't really got into the tracking systems and increasing the panel efficiencies. Yeah, that is something which is still a gray area. So, and this project was, they have used recycled material and minimized carbon footprint. So when we talk about carbon footprint, it is not just about energy and water. It is also about the building materials, how much of recycled content is there, and what is the embodied energy. So when we do a LCA analysis and carbon footprint analysis, we take into account the energy saving in the installation stage, and the energy saving in the operational stage. What is the reduced embodied energy of the material, how much of recycled content and how much of recyclability is there, and what happens to the material after the life cycle. So it's a holistic approach of complete life cycle analysis, from extraction of the material till the end of the life cycle of the building, and that material goes back to recycling or landfill, whatever it is. Based on that, we decide whether we have three approaches in the market. One is cradle to gate, cradle to grave, and cradle to cradle. So this cradle to cradle is going back complete for recycling. Cradle to gate is okay. It goes to the project, but after the life cycle of the project, you really don't know what happens with the material. So cradle to grave is the second level, which is a better than cradle to gate, where you know how the material is reused or disposed. Cradle to cradle is complete or maximum reuse of the material to remanufacture the product or use it in a different way. So this is a project in Germany. Again, 4x more energy than it uses. Solar facade and ultra efficient envelope. So these are few aspects where I was talking 4x more energy than what you use. And heat recovery ventilation, because of the cold climate, and you can also in most of the residential projects or in commercial projects in cold countries, they they recover the heat from kitchen heat or solar heat, and they use it for space heating. And triple glazing windows, because they want to restrict the heat inside the space rather than losing it to the chilled exterior. So this building has already achieved net zero energy with 930 kilowatts rooftop solar BIPV, that is building integrated photovoltaic. And you have a north-south orientation, central atrium, cross ventilation, daylight covering 75% of the floor space, then efficient envelope and HVAC. HVAC, chilled beam HVAC concept in HVAC, which is like similar to radiant cooling, but it can be 40 to 50% efficient than conventional air conditioning, whereas radiant can be 60 to 65% efficient compared to conventional air conditioning. And also 50% lighting energy reduction. They have done a lot of daylight integration, occupancy sensors, and smart LMS system, lighting management system. So they have achieved it through that. And water and material efficiencies, rainwater harvesting, recycled fly ash bricks, and bamboo jute composites, and low VOC paint. So all these things come into the materials efficiencies. Yeah, so basically, sustainability is a necessity, not a choice. So that is a statement what we need to make in the industry, where sustainability is not just a necessity or uh, is a necessity. It is a necessity, but not a choice, because we are depending on the natural resources, and natural resources are exhausting, and we need to see that how much of natural resources really remains for our future generation. No, definitely it can be incorporated into the existing building, because existing building, you know, the challenges what you need to address in renovation of the building and systems. So I would say definitely there are a lot of chances that you can get into regenerative architecture and architectural renovations and retrofit solutions to your system in existing building, and definitely it's a possibility. But it needs a proper understanding of the existing scenario, and engineering and architectural upliftment. So all these things needs to be done, and it is not just the systems. There is a catch here. If you want to keep your architecture and facade same, and if you want to get into regenerative, you can do it. But I say regeneration or giving back renewable energy to the grid, you can still do it, but in that way you will not be optimizing or reducing the cost impact on doing that, because already your building is inefficient. You heat lot of heat load coming into the building, daylight not utilized, and still you want to get into regenerative thing of renewable energy. It's a big no. First you need to handle the building facade, increase the daylight, reduce the heat gain, optimize your HVAC system, lighting system. So because what we have found from our experience is that if you see HVAC system, by building and building optimization and glazing optimization, shading, and selecting a efficient HVAC system, you are able to reduce 45 to 50% of your heat gain and operational HVAC energy. One thing which I could suggest, easy to use, which any architect can use, is developed by World Bank and International Finance Corporation. Many of us would have heard of EDGE tool, EDGE, EDGE tool. So if you type EDGE Green Building Certification in Google, it will take you to the web page where you can register yourself and use a free Excel-based tool, where it is as simple as giving your building plan, your north orientation facade area, south orientation facade area, U value of the glazing. All these things, if you input, it will show you where you stand, and you keep on improvising your building parameters on building envelope, building systems, and everything. It will, and also you can put the percentage of renewable energy system what you can install and based on your economical constraint or the site constraint, and hot water system, heat recovery system. Everything is integrated into the tool, where you don't really have to model the building physically, but you need to give certain building facade and building height and number of floors and building footprint parameters, and wall to window ratio, and shading parameters. So all these things can be input with very handy information what an architect has project. So if it is a residential thing, I would say in residential, if you are handling the building sustainability aspects, heat gain aspects in a appropriate way from the design stage, uh, I don't see air conditioning requirement, at least in climates like Bangalore, which is a moderate climate. Yes, in places like Delhi, which is a composite climate, you may require air conditioning to a certain extent. But there also in air conditioning industry, there are a lot of two-stage evaporative cooling systems which can really keep you at a moderate cooling level even in places like Delhi and Hyderabad, and people have started using it. So you can really look at electromechanical HVAC systems which are efficient, and there are systems which are not like cooling but giving you that comfort with evaporative cooling or two-stage evaporative cooling. So residential, if you ask me, you can look at a two-stage evaporative cooler system. But if you really require air conditioning, you need to go for VRF systems with high COPs, means coefficient of performance above 4.1. So that would be, I would recommend for residential, because concepts like chilled radiant cooling, which is appropriate for offices, may not be able to you may not be able to operate it, install and operate it in residential projects. But yeah, residential, you can go for a efficient VRF system, variable refrigerant flow, what we call it as. But offices, definitely we can go for the economical option. When you say for efficient cooling, first thing would be the UFAD, underfloor air distribution. You guys would have come across raised floor, and that we can raise it up to 350, 400 mm and go for a underfloor air distribution, where your underfloor raised floor helps in networking, electrical cabling, and easy flexibility for changing the workstation configuration in your project. But at the same time, pump in air from below. So the advantage of that is you have if you have a top discharge and top return in a office building, you need to cool the supply air much more. Like the supply air temperature will be 13 degrees, 14 degrees. But when you have a bottom discharge and top return, it's a unidirectional flow of air, and you can just cool your supply air up to 17 degrees to 19 degrees. So you're saving on the chiller power consumption, and you're cooling the building more efficiently. But beyond that, if you want to get into much more efficient system, definitely radiant cooling is more appropriate. Today we are in a more efficient scenario, or the green building scenario, where at least we are confident of reducing 60% of water consumption in our buildings, and 40 to 50% of energy consumption in our buildings compared to conventional buildings. So next level is sustainable building, and what we are heading to is the net zero scenario of energy, water, and even waste. But yeah, net zero energy approach is something which I can say that, as I mentioned, that renewable energy utilization in your projects is not merely restricted to on-site renewable energy installations. The regenerative aspect also comes into flora, fauna, and ecology, what I was mentioning, where you develop that kind of leaf area index. So leaf area index is a very good index to analyze and use in your projects, developed by University of Singapore, where you analyze for every square meter of your green seen in plan, how much area of leaf you have. So a good leaf area index is between 1:4 or 1:6, means one square meter in plan, what you see as a bird's eye view, may have 6 meter square of leaf area or 4 meter square of leaf area. So it also makes you think what kind of landscape you want to have, and that will automatically create a positive impact on reducing the heat load in your buildings and inviting more birds and other species, and it will also conserve water in your project. So all these things are regenerative. So now there is a clear line between what we just call as sustainable projects. So we have not reached that maximum level of sustainability also, because we are not, all of us are not net zero in all aspects of energy, water, and waste, and we have a long time to go. And regenerative is few projects, if you can rethink, or if you can think of giving it back, and also having having invited more flora fauna into your project, you can call it as regenerative. No, green rating, I would say it is, we have done the damage and we are trying to pull the strings and, trying to control the damage what has been done. So green rating, I can say it is just a tool. I think I mentioned previously also in this presentation that Green rating or any certification is just to say that, okay, be sustainable to a certain extent. But definitely, if we, at least in the medium-sized projects or residential projects, if not huge IT parks, may still rely on renewable energy purchases and other things. But at least medium-scale commercial projects, office projects, and residential projects of medium scale, we can definitely try and achieve regenerative architecture in terms of planning and energy utilization and ecologic flora and fauna.
Great. This has been an amazing session. Deepak, thank you so much for discussing various aspects of sustainability. I thank everybody who has joined here. And also going forward, you will see this conversation on YouTube. I will request all of you to drop a line in terms of what you would want to hear next from Deepak and upgrade your understanding of sustainability-based designing. So thank you so much for your time and really appreciate it. Thanks, everybody.
Thank you, everyone. Thank you, Meghna. Thank you.